أعوذ بالله من الشيطان الرجيم. Bismillah ar-Rahman ar-Rahim. In the name of God, most merciful, ever merciful, and may God's peace and blessings be upon His holy Prophet Muhammad and the purified members of his household and progeny. Allahumma salli ala Muhammad wa ali Muhammad. A couple of lectures ago, we started talking about some of the reasons why someone, instead of relying on the logical validity, the strength of the arguments establishing the existence of Allah subhanahu wa ta'ala, and although we haven't talked about it directly yet, everything that will derive from that, which is belief in the possibility of a religion, living your life in a certain way, and so on and so forth, why some people may, or some societies or some cultures may decide to not engage with the logical validity of what you're proposing. So it's not about the strength of the arguments. They fixate on other things that honestly are almost psychological barriers, because it, for instance, disallows people to live the life of freedoms, comforts, the lifestyle that they want, and so on and so forth. Other major reasons, for instance, are that there are historical reasons, political reasons, human rights reasons. These are reasons that either people had and experienced as a result of trauma. So these are things that people experienced as a result of trauma personally or as a society. And there can be a strong reaction to those. See what religion caused. Men of God, men of religion destroyed societies, ruined history, economy, politics, so on and so forth. So as we said, it could be political, it could be human rights, other things at a personal level and a societal level. So these are all reasons for not engaging with the actual validity of the arguments. Then we moved on to, okay, so if people are not falling in line with what we called the divine or the theistic worldview, the worldview that has God in the middle, okay, theocentric, let's call it. So a worldview where God is at the center of your worldview, then the only other alternative today is to have a materialist worldview. So a worldview where you have matter at the center of your worldview. So what we talked about, and last time we got together, was the main principles. If you have a materialist worldview, the main principles of that belief system, the main principles upon which you're gonna build your worldview and live your life. So we said for the main one, and everything is relying on that one, the main one is to believe that existence equals matter. There is nothing beyond matter. If it exists, it's material. And therefore the way to get to it is also through empirical or material means. The second principle is that matter is uncreated, is completely eternal. Matter becomes the ultimate cause for anything and everything that happens afterward. The third principle that we talked about is the principle that says there cannot be any purpose, there cannot be any design. Because the moment you open the door to design, you have to say design requires a designer. And if you remember the way we explained the proof of design from design, we said it's basically two premises. One of them is that the world has design, and the second one is, and design needs a designer. So if I don't want to get trapped into this, I have to close the door right from the beginning and I say, there is no design. The world doesn't have design. It's all random by chance. There is no design. The moment I say there is design, I have to explain where it's coming from. Now I have to come up with a reason to convince you that there is design, but it doesn't need a designer. That's too difficult. So I close the door right from the beginning and I say there is no design. Whatever you consider to be design is actually an illusion. It doesn't exist. And then we drilled a little bit further by saying that anything that we consider to be a natural phenomenon in the world is actually nothing but the result of material interactions. So energy, matter, particles, physical laws, natural laws of the universe explain everything. And as we said, the underlying principle in all of this is that the only way to access all of this and to study all of this is through empirical means. So you have to rely on your five senses to have access to this world. And once you access it, everything and anything that you need, you are going to find in this material world that you just access through your material means. That's where we left off at the last time. Before jumping, and I was going to lump a few topics together, to be honest with you, but I decided at the last minute today that how about we spend just a little bit longer on this? I think it could be more interesting. You guys are engaged with the topic. I think it's not only interesting theoretically, I think it's representative of the world we live in today. The majority of the objections, the questions, the issues, everything that we deal with, the majority of issues that we face as religious people, as believers in God, as believers in a religion, have to do with this materialist worldview. So I have 3 topics in mind, but we'll see. So today I'm taking the first topic that initially I thought I'll cover in 5 minutes. But I decided at the last minute, you know what? Let's make it today's topic. That's all I'm going to talk about today. These are examples of what we talked about. So now we know the theory. We didn't go into a lot of examples. You guys know how to apply those examples. But I decided to try to push your thinking a little bit. I'm not going to give you random examples. I'm going to try to give you examples that show today the most advanced theories of science or the materialist worldview. Where are they and what are they saying? And I'm hoping that this gives you 2 things. First of all, it gives you awareness of who is saying what, who are the big names, what are the big theories. If you want to engage in this kind of thinking and this kind of world, you need to know what's going on. And this is a lot of reading and a lot of thinking and a lot of research goes into this. I'm giving it to you so that you're aware of what's out there. That's one. You're aware of the issues. The second part that goes with this is you are actually aware of some of the answers. We are not going to be able to go in depth in all of this, and you're going to see why today. So what I did today is I'm bringing you a specific book, and I'm showing you what that book actually says. This book is considered top of the line in this field. It's very representative. It's written for this purpose. It's not a book written for another purpose, but it's being used by others to say things about God or religion. The point of the book, and I will come back to this at the end, the point of the book is to talk about science, specifically to show that science is against God and to show that specifically science is against religion. That's the whole point of the book. So if you keep all of this in mind, not only do you know what's going on, what are the most recent issues, and we're not talking about things, I think we presented enough from medieval scholastics and philosophy and things that we talked about, they've been talked about for the past 2,000 years. The things we're talking about now, this is what's happening today in the scientific world, in the polemics and the debates that are happening. Well, that's what the public sees, and people who are intellectuals and thinking about things, this is what they're hearing and what they're saying. So I thought I'd bring it to you, and then at least it pushes you to go research this stuff more, see what's out there. I'm not telling you I've researched these to death. I'm telling you this is what I know is going on out there, and we have a very quick, superficial discussion about it. That gives you awareness of what's going on, and at least the beginning of some good answers of, generally speaking, how to address these issues. Okay? So, the point, the main theme, the topic is materialism. Materialism as a worldview, as an ideology, based on the principles that we presented last time we met. And they can all be summarized into the one principle, which is matter equals existence, or existence equals matter. So let's start with the first topic that I think is quite interesting. So let's talk about the beginning of the universe. That's topic 1. So today, that's the topic. Beginning of the universe. So the book I chose for today is a book that I've mentioned before by an astrophysicist, a theoretical physicist by the name of Lawrence Krauss. Very activist, very well known as an atheist, activist against belief in God, against religion. Same line of thinking as Richard Dawkins and Sam Harris and others. But this guy is a specialist in So Richard Dawkins is more into the biological field. This guy is physics, theoretical physics. One of the books, this book was released in 2012, and it's actually called A Universe from Nothing. Okay, so he presents in this book how to understand the existence, the emergence and existence of this world, with a initial point of what he calls in the title, nothing. Big claim. When I go, let's say I go to, this is a borrowed book, but let's say I wanted to buy this book from the library. Okay, do you guys know who Sam Harris is? One of the biggest names today in the world against religion, belief in God, very vocal, considered a very big intellectual, and so on and so forth. And maybe we will bring a few of his books here too, eventually. So Sam Harris is one of the first it's the first one who writes the little eloquent little spiel behind the book to say, buy this book. He says, in A Universe from Nothing, Lawrence Krauss has written a thrilling introduction to the current state of cosmology. So cosmology is the study of the universe. Cosmogenesis is the study of the beginning of the universe, the genesis of the universe. Anyways, the branch of science that tells about the deep past and deeper future of everything. As it turns out, everything has a lot to do with nothing, and nothing to do with God. This is a brilliant and disarming book. Others, beautifully navigating through deep intellectual waters, Krauss presents the most recent ideas on the nature of our cosmos and our place within it, a fascinating read. A series of brilliant insights and astonishing discoveries have rocked the universe in recent years, and Lawrence Krauss has been in the thick of them. With his characteristic verve and using many clever devices, he's made the remarkable story remarkably accessible. The climax is a bold scientific answer to the great question of existence. Why is there something rather than nothing? It's very promising, right? I'm intentionally reading this. Martin Rees, I'm not going to read because I think he's very diplomatic in what he wrote. We've mentioned Martin Rees. We said he wrote the book Just 6 Numbers. In this clear and crisply written book, Lawrence Krauss outlines the compelling evidence that our complex cosmos has evolved from a heart-dense state, okay, that part we all know, and how this progress has emboldened theorists to develop fascinating speculations about how things really began. It doesn't say more than that, and so on and so forth. Okay, so that's the claim. So what we're going to do, we could spend a lot of time on this, so what we're going to do is simply read a few passages from the book. That's it, and we'll comment on some of them. So I tried to create a little bit of a structure. I read the book quickly and identified passages that I could remember as I was reading. So I'm trying to create a little argument by putting all of this together. And then in the discussion part, we can talk about what this all means for us. Okay, it should be pretty clear. This first one is, just because we mentioned this as a principle last time, I'm mentioning it quickly. It's just a quick one line. A couple of passages are about a page long, but the others are one line here, a paragraph here, okay? The first one I thought was very interesting for a book like this to say something like this. So it says, clearly, the energy of empty space cannot be physically infinite. I repeat, cannot be. The energy cannot be physically infinite. So if ever you need that argument, you know where to find it. Page 71, Lawrence Krauss, not for this book, for anything, any encounter you ever have. This is Lawrence Krauss, completely against God, and he will repeat it again and again in religion. If you ever need those arguments, I'm just highlighting them for you. Clearly, the energy of empty space cannot be physically infinite, so we have to figure out a way to do the calculation and get a finite answer. So I don't have anything more to say. I just thought it's an interesting quote from this guy in this book, so keep it in mind. Okay? That's quote number 1. And the reason why are we mentioning this is because sometimes we say what we need is an infinite. Matter is infinite, energy is infinite, and so that becomes everything you need to know to explain everything. So this is good to know, just keep in mind. Page 58, this is a paragraph long. This is where, and we have a few passages here, all of them together form a couple of pages, maybe 3-4 pages long. All of them together, the title of the book is A Universe from Nothing. So here, what we're trying to do, I have identified a few passages where the physics and the math is not too advanced, and as we read them, we put them together, we're supposed to understand, what does he mean when he says nothing? A universe from nothing. What do you mean by nothing? Let's agree on nothing first. I mean, the whole point of all of this is to see how can a universe emerge from nothing. So we have to agree on what nothing means, right? So he says, by nothing, I do not mean nothing, but rather no thing. In this case, the nothingness we normally call empty space. Okay? I'm not going to comment, but please keep in mind so that we can come back to it. Nothingness, the nothingness we normally call empty space. That is to say, if I take a region of space and get rid of everything within it, dust, gas, people, and even the radiation passing through, namely absolutely everything within that region, if the remaining empty space weighs something, then that would correspond to the existence of a cosmological term such as Einstein invented. So this is his first definition of nothing. It's absolutely empty space. We're not going to go into all the physics here, but basically it's almost realistically, it's impossible to create a complete vacuum in a space. You go into a part of the universe and empty it of anything that's there, that's very difficult to do. There's always something going through. Okay? So the real vacuum, he's saying that his idea of nothingness is to go to a place, a part of space that is completely empty of any of that, and that's what we refer to as nothingness. Nothing. This is implying something, though. This is implying that we're still working with this space. The space that exists in the current universe. All he's done to it is that he's emptied it from anything that's in it. So here, keeping in mind, that our question to him is that real nothingness? Is that the type of nothingness we want to ask the question, what was there before this world, before this universe? If we say nothing, is that the nothing we're both talking about? Is that what we understood when we said the universe is created out of nothing? In philosophy they say ex nihilo, out of nothing. Or is that something? Is space something or nothing? Okay, so that's one part. 2. Page 142. When you are faced with a profoundly simple underlying order, so you look at things and they look like they have a lot of design. They have a lot of purpose. They have a lot of order. When you see that, you can draw two different conclusions. One, drawn by Newton himself and earlier espoused by Galileo and a host of other scientists over the years, was that such order was created by a divine intelligence responsible not only for the universe, but also for our own existence, and that we human beings were created in her image. The other conclusion is that the laws themselves are all that exists. Okay, so did we notice the two alternatives he's giving us? He's saying when we look at the world, when we study the world, and we see that it looks like it has order, we can only come up with two alternatives logically. One of them is the one that people like, nobody's like Newton and Galileo followed, which is there's a God that created this world with these laws and us in it. Okay? The other conclusion is that the laws themselves are all that exist. So there's no God and there are only laws. These laws themselves require our universe to come into existence. Does that make sense? Like, you understand what he's saying? It's clear? We're not debating the content. I just need you to understand what his claim is. His claim is the laws themselves require our existence, our universe to come into existence. The laws require the universe to come into existence, to develop and evolve, and we are an irrevocable byproduct of these laws. So basically there's no way but it's determined. It's necessary. Once you have these laws, that this is what's going to happen. The universe is going to exist because these laws are there. The laws may be eternal, or they too may have come into existence, again by some yet unknown but possibly purely physical process. Okay? So we saw what the two alternatives are.
So he's saying the second alternative is that the law started everything, but then he said that those laws need the universe to be the laws.
No, he didn't say that. He said these laws themselves require our universe to come into existence.
But the law started everything.
But the law started everything. Yeah, so that they started the universe. The laws started the universe.
They started the universe, but they need the universe to be the laws.
No, they don't need anything. The laws are there by themselves. Okay, let's go to page 97, 98. Page 97 starts. Now we're going to keep thinking about, we're trying to understand what he means by nothing. So the universe came out of nothing. We're trying to understand what he means by nothing. He's going to slowly, these quotes are slowly going to tell us what he means by nothing, while telling us how can that be. Okay? As I have described already, the laws of quantum mechanics imply that on very small scales for very short times, empty space can appear to be bubbling brew of virtual particles and fields wildly fluctuating in magnitude. Okay, so basically, it's like, imagine that there's water boiling. What do you say about that? It's like in an unstable state. You can't say that it's liquid. You can't say that it's gas. You can't say that it's stable, right? There's stuff happening. And it looks like it's kind of random. Things are happening. The way he's going to explain it to us is as though this is the point where things come and go into existence. You know how these bubbles form at the surface of boiling water? This is how things enter into existence, because it's like they're unstable. Okay? I just need you to understand the claim. We're not evaluating the content. This is a very important term he's going to use here. If you're interested in this topic and you ever want to look it up, this whole thing that he explains falls under a general theory right now in quantum mechanics called quantum fluctuation. So a quantum fluctuation basically means there are situations that some scientists have actually tried to create, or they have created, where they can create a particle from nothing. So our whole discussion is, what is this nothing? Is it really nothing? But basically a particle appears and the antiparticle, so that's another thing in physics. So there are particles and there are other particles that are like if you were to put a mirror, they look like they're in another world, the same particle but with opposite qualities. And they need those to make sense of all the math and all the laws of physics right now. If you remove those, there's a lot of problems with the physical laws. Okay, so every particle has a particle on the other side. Antiparticles. So quantum fluctuation is when you have a situation, you create a situation where one of those particles, as well as its antiparticle, appear. Okay, that's the theory. So here he's explaining that. So he says, as I have described already, the laws of quantum mechanics imply that on very small scales, for very short times, how short? Very short is you cannot measure it. Okay, and that's why sometimes they refer to them as virtual particles, because they cannot be measured. It's too short of a time span. Very short time, empty space can appear, but again, empty space. We're still in space. He does not accept that we ask where is space coming from. Empty space can appear to be a boiling, bubbling brew of virtual particles and fields while fluctuating in magnitude. These quantum fluctuations may be important for determining the character of protons and atoms, but generally they are invisible on larger scales. So this is not something that we can generally be able to measure directly, to see, to observe, but we know they're there mathematically, or at least we can posit them and say that they exist. Okay, so we're starting to get an idea of what he means when he says nothing. This is the sort of stuff he's talking about. It's not measurable, it does not have any weight, but it exists. It's space, but it's empty space, but it's space. what else is there in that? There's one more thing, and all of this is going to come down at the end with a couple of good quotes, okay, from Hawking and others. If inflation indeed is responsible, so what's inflation? Inflation is the idea that the universe is expanding. It's the expansion of the universe. That's inflation. So now we have space, we have the laws. So in this case, he's specifically talking about quantum fluctuations, so he needs quantum mechanics to make sense and to be in place, at least. So we have some natural laws that are in place. As he said earlier, the laws are all that is there. And from the laws, the universe comes out. And we have empty space. And now we have inflation. So this is the nothing. The idea of the nothing from which the universe is coming from is starting to be clear. Okay, now we're at the inflation stage. If inflation indeed is responsible for all the small fluctuations in the density of matter and radiation that would later result in the gravitational collapse of matter into galaxies and stars and planets and people, then it can be truly said that we all are here today because of quantum fluctuations in what is essentially nothing. So the quantum fluctuation, combined with the laws of nature, combined with inflation, make something become matter, an energy that becomes matter. When it collapses on itself, it becomes matter, and that matter becomes dust, and then galaxies, and stars, and planets, and people, and they evolve, and we are here today. Okay, so that's the theory. This is so remarkable, I want to stress it again. Quantum fluctuations, which otherwise would have been completely invisible, get frozen by inflation and emerge afterward as density fluctuations that produce everything we can see. Okay, the punchline is yet to come. I haven't said it yet. If we are all stardust, as I have written, it is also true, if inflation happened, that we all literally emerged from quantum nothingness. So again, my question is, if it's quantum, is it really nothingness? The next paragraph, I'm not going to read the paragraph, just the first line. This is so strikingly non-intuitive that it can seem almost magical. Good, we agree. Okay, let's go now to page 156. We're still trying to see how all of this is working and what we mean when we say the universe may have come out of nothing. Page 156. Nevertheless, all of these phenomena imply that under the right conditions, not only can nothing become something, it is required to. Please keep this idea in mind. It's very important for anyone who is into this field and who is looking into these arguments or debating with people who are into astrophysics or theoretical physics or so on and so forth. This is another strategy. This strategy is not only can there be something out of nothing, the only way for something to exist is to come out of nothing. This is the claim. The only way for the universe to exist, their claim is by following the natural laws, and the natural laws tell us that the only way for something to exist is to come out of nothing.
Who says that?
This is these theories. Stephen Hawking, Lawrence Krauss.
They say natural laws say that we have to come from nothing?
Yes. So this kind of reverses the traditional.
Would it still contradict that that there's a God?
We're not talking about God.
Okay.
Now we're talking about what these physics are trying to say.
Okay.
The claim is that, and that's why I'm saying it's completely counterintuitive. Two, you may go into these debates preparing for a certain type of argument. This comes back with the opposite strategy. The strategy now is not only can the universe come out of nothing, it has to come out of nothing. There could not have been something before, It must have come. So don't come and explain to me the universe with God. I don't need God. All I need is this theory. Do we agree that there is nothing? Yeah, that's all I need to be here today. This is a strategy, and we'll come back to it. Okay? But this is the opposite of what we are usually used to. And that's why we said that when we presented the, let's say, the simpler form of these arguments, we said the main principles of materialism, we said matter may be uncreated. It's always been there. It's eternal. Right? And we refuted that. We said why that cannot be. And even if it is, it's still contingent. It still requires a necessary being. This is another strategy. Strategy now is actually the only way for anything to exist is as a result of nothingness. Why? Because nothingness is unstable. So it creates something out of nothing. But what's the nothing? Again, what's the nothing we're talking about? It's space with the laws of nature, the laws of quantum mechanics that can cause quantum fluctuations. And quantum fluctuations with inflation can create energy to collapse into matter. That's the argument. However, sorry, I skipped a line. An early example in cosmology of the fact that nothing can be unstable and form something comes from efforts to understand why we live in a universe of matter. I'm going to skip the rest of this page. At the very bottom, 156, I'm saying the numbers, so if you ever go back and read. However, if our universe began sensibly with equal amounts of matter and antimatter and stayed that way, we wouldn't be around to ask why or how. Okay, why? So I'm going to explain it and then I'm going to read it. We just said these theories say that for something to exist today, when we look at things, there is matter. But for everything to make sense, matter is made up of particles. And on the other side, it's like there's a mirror universe that we don't see, but it's there. There's antiparticles. For the math of the physics to make sense, they postulated that there has to be antiparticles. And with enough experiments, they discovered a lot of them. For every type of particle, they found an antiparticle. Similar, has the same attributes, with some of them being the exact opposite. Okay? The problem is, if you have the exact same amount of particles and antiparticles, you get at the end a big fat zero. They cancel each other out. And that's why in a quantum fluctuation, they make it come into existence. But what comes into existence? It's something that doesn't change the energy, the total energy. So the particle and the antiparticle appear together. It's like when you have math and you multiply both sides by the same number. Okay, so that you keep the balance. You cannot just mess up your equations. For everything to make sense, every time there's a particle, there has to be an antiparticle. Okay, the problem this causes is that if there's one of each, they cancel each other out and nothing happens. So this tells us that assuming all of this theory is correct, this tells us that something must have caused a little bit more matter to exist than antimatter. A little bit more particles than antiparticles. Something must have done that. For anything to exist afterwards, there had to be a little bit more matter than antimatter. A little bit more particles than antiparticles. This imbalance makes matter come into existence without being annihilated. So every particle that has an antiparticle, that goes to a zero. What's left? The leftover, if there is, that's what's going to end up existing in our material world. So the leftover has to be a bit more matter. Make sense? That's what he's going to try to tell us now. I'm going to read it quickly. This is because all particles of matter would have annihilated with all particles of antimatter in the early universe, leaving nothing but pure radiation. No matter or antimatter would be left over to make up stars or galaxies or to make up all of the rest. Okay? Scientists began to understand in the 1970s, however, that it is possible to begin with equal amounts of matter and antimatter in an early hot, dense Big Bang, and for plausible quantum processes to create something from nothing. How? By establishing a small asymmetry. Asymmetry meaning that if you put them both one beside the other, one side is a little bit different, right? We all know what symmetry is. The symmetry here is between matter and antimatter. So in the 70s, he tells us, when the scientists got together and put all of this, they said for any of this to actually make sense, we have to expect that there was an asymmetry with a little bit more matter than antimatter. Okay? A small asymmetry with a slight excess of matter over antimatter in the early universe. Then instead of complete annihilation of matter and antimatter, leading to nothing but pure radiation today, all of the available antimatter in the early universe could have annihilated with matter, but the small excess of matter would have had no comparable amount of antimatter to annihilate with, and would then be left over. This would then lead to all matter making up stars and galaxies, the stars and galaxies that we see in the universe today. As a result, what might otherwise seem a small accomplishment, establishing a small asymmetry at early times, might instead be considered almost as the moment of creation. Because once an asymmetry between matter and antimatter was created, nothing could later put it asunder. Basically, cancel it out. The future of history of a universe full of stars and galaxies was essentially written. The moment you say there was a little bit of a asymmetry. So now what do we need? What's nothingness? There are the laws. There's an empty space with the laws functioning in it. Inflation. And now we have asymmetry. Okay? Page 149. We're going back a little bit. We're going to seal the deal on what he means with the nothing, and then we're going to move to something else. First, I want to be clear about what kind of nothing I'm discussing at the moment. It's good. It's page 149. This is the simplest version of nothing, namely empty space. For the moment, I will assume space exists with nothing at all in it, and that the laws of physics also exist. This is nothing, right? Once again, I realize that in the revised version of nothingness, that those who wish to continually redefine the word so that no scientific definition is practical, important, this version of nothing doesn't cut the mustard. However, I suspect that at the time of Plato and Aquinas, when they pondered why there was something rather than nothing, empty space with nothing in it was probably a good approximation of what they were thinking about. And I'm going to leave too much commentary here, except to say what's something we're going to read in the reviews. If he had studied a bit of philosophy before talking about these philosophers, it would have helped him. I don't think a philosopher in the history of humankind would have agreed with him that space with laws in it is equal to nothing. I don't know how many philosophers consider that non-being. Space. You are saying that there's space with all the laws in it. But he's not happy that those who play around with the terminology, as he says, to make science not work, non-practical for scientific purposes. So his claim is people like Plato and Aquinas, or Aquinas, he claims that they would have agreed with him that space with these laws in it are enough to call it nothing. I don't think so. And he could go back to the works of Aristotle and Plato and see what they think, what they say about.
He's saying people are trying to go fight science, and that's what, and like that's basically ignorance, is what he's trying to say. Like he's calling people ignorant for them because.
Yeah, he says if you go back enough in history, okay, so 2,000 or 1,000 years ago, based on the names he's giving, the big thinkers of that time would have agreed with him that what he's talking about is equal to nothing. Space with laws in it is equal to nothing. But nowadays, because people want to bicker and argue, they keep changing the meaning of the word nothing to make it become something that science can't work with. It's not practical for scientific purposes. That's the whole point.
Well, what is the definition of nothing?
So he's telling you. He just says that's why we've read that many passages. He's saying nothing for nothing to make sense scientifically.
It's not nothing.
Exactly. But he would disagree with you.
Yeah.
Okay? But what he's saying is, for nothing to make sense, the universe from nothing, scientifically, for nothing to make sense, it is the laws of quantum physics, space, inflation, and the last one that we mentioned, the asymmetry. Okay, so how does all of this happen? How does it work out? I've already explained it, but let's say it. This phenomenon happens without the need for any hocus pocus or miraculous intervention. This is possible because the gravitational pressure associated with such energy in empty space is actually negative. This negative pressure implies that as the universe expands, the expansion dumps energy into space rather than vice versa. So this is inflation. But now he needs gravity, which is one of the laws. Okay, the gravitation is one of the laws that he already told us exist. Now he's going into one of them. According to this picture, when inflation ends, the energy stored in empty space gets turned into an energy of real particles and radiation, creating effectively the traceable beginning of our present Big Bang expansion. Okay, let's go to page 151. So we and everything we see result out of quantum fluctuations in what is essentially nothingness near the beginning of time, namely during the inflationary expansion. A little bit further, page 151. Therefore, our observable universe can start out as a microscopically small region of space, which can be essentially empty, and still grow to enormous scales containing eventually lots of matter and radiation, all without costing a drop of energy, because he works around the math, with enough matter and radiation to account for everything we see today. Skip to the end of the page. It certainly seems sensible to imagine that a priori, matter cannot spontaneously arise from empty space, so that something in this sense cannot arise from nothing. But when we allow for the dynamics of gravity and quantum mechanics, we find that this common sense notion is no longer true. So put aside your common sense. We don't need it here because it's simply not true. This is the beauty of science, and it should not be threatening. Science simply forces us to revise what is sensible to accommodate the universe, rather than vice versa.
So they're doing what they're blaming religious people with.
Yeah. Change whatever you need to change. Thank you. I love how you said that. You're taking the same words we said before. Park your reason, park your common sense. We talked about the role of reason, right? Okay, so we're page 151. So now let's go to the beginning of the book before he even starts talking. So, okay, this is in Roman numbers, page 9, okay? So this is the preface of the book, where he goes on a little bit of a rant against religion and against people who believe in God and so on and so forth. He's not happy that people are not, because initially, just so that you guys know, this was not a book initially. This was a talk he gave. He participates in a lot of polemics with people who believe in God. Those are philosophers of religion and people who believe in God in general. These are public, very large public debates. A lot of these are on YouTube. This was, according to him, so popular. He talks about it. He says on YouTube, this was 1 million views. So I was encouraged by the number of views and the people telling me. I know you guys are laughing because this is not a viral video. But for in the world of astrophysics and theoretical physics, that's really cool. So basically, that talk became the book. He was convinced that it deserves to be explained, and this was his chance to answer the big questions and the big, objections that he heard, and so on and so forth. Okay? This is Lawrence Krauss. Okay, so he's explaining how all of this started. Then he says, so now he goes on a rant because so many people have disagreed with him about his definition of nothing. That now we know what it is, right? We all went through all these passages. We have a pretty good idea of what he means by nothing. He's really unhappy that people don't like his definition of nothing. So he says, nothing, they insist, is not any of the things I discuss. Nothing is non-being. in some vague and ill-defined sense. So he's very unhappy with that. Similarly, some philosophers and many theologians define and redefine nothing as not being any of the versions of nothing that scientists currently describe. A century ago, had one described nothing as referring to purely empty space, possessing no real material entity, this might have received little argument. He says everybody would have agreed with this. It's just empty space, that's equal to nothing. But the results of the past century have taught us that empty space is in fact far from the inviolate nothingness that we presupposed before we learned more about how nature works. Now I am told by religious critics that I cannot refer to empty space as nothing, but rather as quantum vacuum, to distinguish it from the philosophers or theologians' idealized nothing. So be it. But what if we are then willing to describe nothing as the absence of space and time itself? Is this sufficient? Again, I suspect it would have been at one time, but as I shall describe, we have learned that space and time can themselves spontaneously appear. And we're going to show now with a passage from others what they mean. Okay? So let's go to the afterword, written by Richard Dawkins. He wasn't supposed to write it. Hitchens was supposed to write it, but he died. He was an even bigger atheist, and maybe we'll talk about him. He has a few books. One of them is God is Not Great, and other books. He was supposed to write it, but he died. So Dawkins ended up writing the conclusion. So this, Richard Dawkins, it's interesting because if this is a book of theoretical physics, where you're claiming to present a scientific proof, evidence, new theory, why do you have someone like Richard Dawkins right at the end? Richard Dawkins is well known. If he's popular for one thing, it's being against God and against religion. So this, to me, already sets the tone of what the point of the book is. There are much bigger names if you want to go in terms of who are the big names in discovery as scientists, as philosophers, philosophers of science, philosophers of religion, historians. No, he went with Richard Dawkins. Anyways, I'm going to read a passage here, but then I think I wrote it down in the reviews. Even people who said that this is a really good book, they still said Richard Dawkins should not have written that. It's just laughable. He made a joke of himself. So Richard Dawkins here, I thought, is really good because he's summarizing the book. I'm not going to read his other claims of how this is basically equivalent to this book is equivalent to the origin of species of Darwin, that he was able to revolutionize. This is a Copernican revolution. Everything changes once this book is published. Okay, so this was in 2012. So here he's kind of summarizing. So I thought, in case you were dozing off or you came out late or whatever, we're going to summarize a lot of what has been said now in this paragraph at the end of the book from Richard Dawkins. He says, not only does physics tell us how something could have come from nothing, it goes further by Krauss's account and shows us that nothingness is unstable. Something was almost bound to spring into existence from it. Don't laugh. If I understand Krauss aright, it happens all the time. The principle sounds like a sort of physicist's version of two wrongs making it a right. Particles and antiparticles wink in and out of existence like subatomic fireflies, annihilating each other and then recreating themselves by the reverse process out of nothingness. And then I'm going to skip the next paragraph, and he says, what a bizarre, ridiculous notion. Really, these scientists, they're as bad as medieval schoolmen counting angels on pinheads or debating the mystery of the transubstantiation. Here he's basically taking a jab at medieval theologians and Christianity. Okay? Anyways, so pages 143, 144. So we kind of covered until now what he means by nothingness and how all of this would work. Now we understand what it is, and we understand how it would work. Here, all I wanted to say, page 143, 144, I think is an important point. So there's 2 points here. A lot of what we have asked and what we keep saying, that's this entire series that we have been talking about, we've said that there's something fundamental in human beings that they want to understand the why. And the fundamental questions for us human beings is, where do we come from, what are we doing here, and where are we going, and why? That's what we're aiming to get at, right? Fundamentally, why is it the way it is? Why is there something instead of nothing? Why is it the way it is? Why are the laws of nature the way they are? Right? So keeping this in mind, because this is what generates everything else. For instance, for us to say there is design, we notice that things seem to have a finality. It's as though things were planned in a certain way with an intent behind them. In order to be able to say that, we have to recognize that there are patterns, that there are laws that have been put in place. Okay? So keeping all of this in mind, page 143, he says, in science, we have to be particularly cautious about why questions. When we ask why, we usually mean how. And we talked a lot about this. If we can answer the latter, if we can answer how, if we can answer the latter, that generally suffices for our purposes, for scientific reasons. For example, we might ask, why is the Earth 93 million miles from the Sun? But what we really probably mean is, yeah, you heard that. How is the Earth 93 million miles from the Sun? That is, we are interested in what physical processes led to the Earth ending up in its present position. Why implicitly suggests purpose. And when we try to understand the solar system in scientific terms, we do not generally ascribe purpose to it. You see how it all connects now? That's what I was trying to aim at before when we said the materialist worldview cannot accept that there is purpose. And they will be very open about it. The moment you open the door that there is design, that there is order, that there is, they have to close it, because if they accept that line of thinking, then they have to say, where did it come from, or why? So he says, don't ask why. Why is the wrong question. Ask how. Science can tell us about how. And if that's the case, I agree with you. Then don't tell me about the why. I'll find the why outside of science. I have theology, I have philosophy, I have logic, and I can use them to come up with a why. So don't tell me about the why, and let's all agree on this. Or if you want to tell me why, then tell me why. And this becomes scientism, when science becomes a philosophy or a religion. So let's go a little bit further. So I am going to assume, page 144, so I am going to assume what this question really means to ask is, how is there something rather than nothing? Not why is there something, how is there? So what he's doing in this book is not telling us why there is something, he just explained to us how there is something. And how is it? Once again, so that you all remember, there's the laws of quantum mechanics, there's completely empty space, there's inflation of that space, and there is asymmetry.
How is it completely empty space if there's inflation of this space?
Inflation is, it's empty, but it's expanding. That's inflation.
No, I want to know how's the gravity if it's empty space.
It's one of the laws. Gravitation is one of the laws. We agreed that the laws are there. Even before the space, the laws are there.
Is it possible for their space if it's empty?
Yeah, why not? I'll agree with him that it's space, but I don't agree with him that's nothing.
Because
I'll give him that it's space.
if it's empty, that means it's not space. Like it'll just.
It's empty space, but space is still space.
It's like a balloon, basically. Like when you try to suck it out of it, it's like when you blow into it, it doesn't just like when you suck out of the balloon, it doesn't get wrinkly. It
Why
sucks
does it
back
have to
in,
be a balloon?
you know? Like
You're stuck on.
So into the issue is that if you consider space to be nothingness, none of the physics work. In the physics world, space is something. It needs to be explained.
that's what I mean.
It's like an infrastructure. I don't know what field to use as a. It's like the backdrop, the canvas on which you put everything.
The stage.
It's the stage on which everything is happening. Nothing works if you don't explain what space is.
Exactly. So, but what I'm trying to say, if there is nothing,
Yeah.
then there wouldn't be a stage. Shrink up, making it nothing.
So the claim is,
So there wouldn't be.
so what they're really saying, and that's why I said, although the claim is that now the laws are going to be necessary for anything to exist, it has to come from nothing. The reality is that it's not a nothing, and it's going back to what we said, which is, it's eternal. Matter is eternal and everlasting, and it's always been there. So space is always there. And the laws are always there. And don't bug me of where they came from. They're there. So you understand the claim, right? So the claim is that space does not require any further explanation. And in fact, other theories got rid of space, but they said time is the fundamental thing.
Is it time not real?
Well, according to them, time is real.
Okay.
Okay, so we're not going to go into all the permutations of the quantum fluctuation, all the different versions of it. This is one. I thought it was one that would be really good to know because it's very popular. If people who really read and know what's going on in the world, they might know this one. Yes.
We have different explanations of what space is, basically. Like we have a different idea of what.
I'll agree with them. I'm telling you, I agree with them 100%. I'll give him that space was there. Where I disagree with him is I call space something, he calls space nothing. So he claims that if the universe comes out of that space, the universe came out of nothing. I tell him, no, the universe came out of something. So my question is, where did the something come from? I need a necessary cause. We're just pushing the cause back. All I need him to agree with me is that the space and the laws and the inflation and the asymmetry are all somethings. His claim is that all of these together, they're nothing. And so the universe can come out of nothing. And I'm telling him, I'll agree with you. I'll agree with all of your science that doesn't make any sense. I'll agree with it. 100%, you're right. The universe came out of the laws of empty space, of inflation, and of asymmetries, leading to the quantum fluctuation. Good job. Go get a Nobel Prize. Beautiful.
Even then, those are things, they're not nothing.
So my issue is, you're still telling me the universe came out of something. So my question, it's not about the universe. Put the universe aside. I'm not going to ask you about the universe. Now I'm asking about those things. They're things. Can we agree they're things? It's something. He doesn't. His whole point, when his whole book is universe from nothing, we just understood now what nothing is. So this is where he disagrees with me.
And in science, you can't explain those rules, and you don't explain those. You don't say how. You just do it.
Well, basically what he's doing is he's playing around with words. He's claiming that this is the scientific explanation of nothing. And I would tell him that's actually not true. It may be the scientific explanation of nothing of those whose only purpose is to show that God doesn't exist. If your whole point of doing science is to show that God doesn't exist, you're going to say, and therefore all those things, they're nothing. That's the nothing we're starting with. But if you don't care whether God exists or not, you wouldn't call that nothing. And as we shall see, some of those who reviewed the book, they are very big atheist astrophysicists, mathematicians, theoretical physicists. They refuted the book and they said, this is nonsense. Even if you agree with the math and the physics of it, no issue there. And this is the quantum fluctuation is a very big theory today. My issue is, I'm not attacking the theory. Let's say the theory is 100% correct. What I disagree with is everything you wrote here, 150 pages to explain to me what's going on. This is not about nothing. You explain to me how something is working. The quantum fluctuation, you're explaining it to me and you're calling it nothing. It's not nothing. It's something. The laws are not nothing. They have design and they have purpose. Where did it come from? So I'll agree with you. I'll let you talk and you'll explain all of this to me. I'll say the only thing I disagree with, as he said, but he would not be happy with me, as he said right from the beginning, is all these people playing around with the notion of nothing in a very difficult, confusing way. Actually, it's not confusing. Nothing equals non-being. The moment there's something that is, there's being. we're no longer in nothingness. But if he accepts that, he's stuck. Khalas. This is where science stops. So page 169, in any case, while Stephen Hawking and his collaborator Jim Hartle have proposed a very different scheme for trying to determine the boundary conditions on the universe that may begin from nothing at all. See? So that's the point that I was getting at here, is that he proposed one version of this theory. There are others. They all boil down to the same thing. The how is a little different. Some of them emphasize space. Some of them emphasize time. Some of them get rid of both, but there are things that no one can get rid of. One of them is the laws of quantum mechanics, or just let's call them the laws of nature. All of them agree that the laws of nature are always there. So I'm going to read to you what he's summarizing. He puts in 2 points. He's summarizing what Stephen Hawking says. He's saying basically that's another version of what I presented. The other version is, the important facts are these, he says. So this is a summary. In quantum gravity, good start. In quantum gravity, universes can and indeed will spontaneously appear from nothing. In quantum gravity, they appear from nothing. Such universes need not be empty, but can have matter and radiation in them as long as the total energy, including the negative energy associated with gravity, is zero. Okay, so here is where you see the game. The math is one thing. The common human language is another thing. When you have numbers, you can put the numbers together in a way and play around with them to make the math work and create a zero. It doesn't mean that there's nothing there. We all know that. You can play around with equations. It doesn't mean that there's nothing. So what he is saying here, the summary of what Hawking says, is the universe is not empty. It doesn't need to be empty. It can have matter. It can have radiation in them as long as the total energy, including the negative energy associated with gravity, is zero. So if you're telling me that there's a universe that exists, let's say, with a lot of particles and antiparticles, according to this definition of Hawking and Lawrence Krauss, they agree with me that there's a universe that exists with laws and particles and antiparticles, but because the energy total, when they do the calculation, is zero, it's equal to nothing. Okay, so now you're confusing two types of speech. As normal human beings, we do not call this nothing. Welcome to the real world. This is not nothing. This is something that mathematically we can create and manipulate and play around with and make it equal to zero, but we all agreed that there's something that exists, right? Let's put the math aside for a minute and talk about the real world. You just agreed with me there's matter and radiation. And the second thing he says, as a result...
So he's saying we're all created from zero?
No, he's saying that if you have a world where you can have the energy and anti-energy, negative energy, together give you a zero, that's what we call nothing.
Okay.
So they're agreeing with us that there is matter and there's radiation. This is what Hawking is saying in this article with Stephen Hawking and Jim Hartle. He's summarizing their article here. He's saying this is a different version of what I'm talking about. So there's matter and there is radiation, but because the total amount of energy, when I calculate it, is zero, it's equal to nothing.
But it's a lie though. It does not equal to zero.
No, it does equal. I'm not disputing how they do physics.
Then how could there be something if it can equal to zero?
Because the math works out to zero.
It's like you have a 2 here, but on the other side of the equation you put a -2.
Bro,
So
1
you bring
minus
it-
1.
But
Yeah, I understand.
But there's a 1.
But there's a one. Like, why is there a one?
Where is the one?
Like, where'd they get the one?
How?
No, we're not. We're saying we agree with them that when you actually manipulate the numbers mathematically, when you plug the realities of the world in physical equations, you may get a zero.
Yeah.
The total sum of the energy, it's like I put two magnets. Okay? Let's use that example. You put two magnets together.
Yeah, it cancels out each other.
Okay, the canceling out, because when you calculate it and you say, so what's moving? And you say nothing moves now. The canceling out makes nothing move. The zero I'm looking at here, this is what I'm calling nothing, therefore there's nothing here. No, there's two magnets. And there's an energy and laws at play here. You can't call all of this nothing just because mathematically you got a zero. You're looking at one thing. Okay, so that's, yes, exactly. Okay, the last two paragraphs of his book. The lesson is clear. Quantum gravity not only appears to allow universes to be created from nothing. You're still with me? Quantum gravity not only appears to allow universes to be created from nothing, meaning in this case, I emphasize the absence of space and time, it may require them. Nothing, in this case, no space, no time, no anything, is unstable. Moreover, the general characteristics of such a universe, if it lasts a long time, would be expected to be those we observe in our universe today. Does this prove that our universe arose from nothing? Of course not, but it does take us one rather large step closer to the plausibility of such a scenario. Okay, so at the end he's closing with, I can't, tell you 100% that that's what happened, but that's a pretty good explanation of what happened. Okay. If you're interested, there's a talk by a philosopher of science, a mathematician. His name is John Lennox. He talks about one line. He has a whole talk about one line from Stephen Hawking. Same kind of thinking, but not from anything we talked about today. So if you're looking for another reference, and it's a quick, easy YouTube video, very, very well known. The line from Stephen Hawking is, because there is a law of gravity, the universe can and will create itself out of nothing. So he's giving a public speech, and he destroys this on, I think, 4 different levels, showing that, even very smart people can say very stupid things. So because there is a law of gravity, the universe can, not only can, and will, and must necessarily create itself. The universe will create itself out of nothing. Okay, so I think you can see where the talk goes and how he explains that. Anyways, so I wanted to read very quickly, I wanted to read 2 parts from 2 people who wrote reviews on this book. Both of these guys are atheists, against God, against religion. One of them is David Albert. Okay, this guy is considered a philosopher of science, but he has a PhD in theoretical physics. Okay, so he's both a philosopher and a physicist. He says, the particular, eternally persisting, elementary physical stuff of the world, according to the standard presentation of relativistic quantum field theories, consists unsurprisingly of relativistic quantum fields. They have nothing whatsoever to say on the subject of where those fields came from, or of why the world should have consisted of the particular kinds of fields it does. Like it does have. Where do these fields come from, and why is it those fields of the quantum fields? Or of why it should have consisted of fields at all, or of why there should have been a world in the first place. Period. Closed case, end of story. So basically, and he's well known, this caused a huge controversy in the scientific community when he wrote this. This is just a tiny part. He wrote a long review in the New York Times when the book came out in March 2012. And this caused a huge controversy, and it became a huge fight between Lawrence Krauss and this guy. Because his review was basically, this is a waste of time. Don't even read it. It's a stupid book. He's claiming that he explains nothing, and he doesn't explain anything. Okay. Sean Carroll, philosopher, here's another guy. So he wrote a review that I thought, when I read it, it's a long review, when I read it the first time, I think he's trying to bring all these scientists back together and saying, like, you're all a little bit right and a little bit wrong. So here are 2 quick passages from him. In one part, he says in that review, nothing about modern physics explains why we have these laws rather than some totally different laws. Although physicists sometimes talk that way, a mistake they might be able to avoid if they took philosophers more seriously. Elsewhere in that review, he says, and so this is important, these are atheists, astrophysicists, mathematicians, theoretical physicists, big thinkers in that field. Okay? You guys need to know this and to know those arguments and where they stand, so that you're able to deal with when you hear this is what physics says and what physics can't say, this is what can physics prove and not prove, and we at least know what's going on. What are they talking about when they say we've actually been able to create a particle out of nothing? What kind of nothing? Is it the quantum nothing or real nothing as a non-being? What are we talking about? Do advances in modern physics and cosmology help us address these underlying questions? What are the underlying questions? So he's saying all the advances in physics, these and all the others, are they going to help us address these underlying questions of why there is something called the universe at all, and why there are things called the laws of physics, and why those laws seem to take the form of quantum mechanics, and why some particular wave function and Hamiltonian? In a word, no, I don't see how they could. Clear? This was in an article in Discover magazine, December 2018, so very recent. All this to say, where we started off last week was to go through the principles of materialism. We went through the general principles, the theory behind it, and we explained it. If we want to talk about, at the simple level, what it is, what we mean, we took it this week to something a lot more sophisticated, to the most advanced research and theories in theoretical physics. And we went to a guy who, if you read the book from beginning to end, you see how much he talks about God and that God is not required and there's no place for him. And everywhere he can, he takes jabs at religion. And you see, as we said, the whole purpose of the book seems to be that you don't need religion. If you understand this, you've understood everything, including the fundamental questions. And I think that was the whole point of the title of his book. Right? So this was one of the biggest questions. The initial why, the first why, the first beginning. Now we know what the most advanced version of science has to say about it today. Not 50 or 200 years ago, not 5 centuries ago. This is going on today. This is what science is working on today. Okay, so in the next couple of lectures, we'll try to do the same thing, but maybe with a couple of other topics that maybe I consider to be hot potatoes, hot issues right now, similar to where does the universe come from. And I think with those put together, we're going to have a pretty good idea. We understood the theoretical foundations of what they said. We're now going through concrete examples. Once it's applied to a specific field, like the beginning of the universe, beginning of existence, as they consider it, or the beginning of life, or the beginning of consciousness, what does it look like? And to what extent can we rely on what they're saying? To what extent does materialism have answers today? For those who say you don't need that, we have all the answers on the side of natural science. Okay? وصلى الله على سيدنا محمد وعلى آله الطيبين الطاهرين.